Hello and welcome to the Daily Space for Tuesday, July 24th of 2018. I am your host, Dr. Andres Plazas, and as always, we're going to bring you a run-up of today's news from space and astronomy. So today we're going to start talking about the moon again, as we did yesterday. And this is today we start with a study from the Astrobiology Journal from Washington State University researchers that say that while today, of course, we know that the moon is uninhabitable, you cannot find we haven't found any traces of life today, but they say that there could have been life on its surface in the distant past. So the researchers said that the conditions on the lunar surface they were sufficient to support simple life forms shortly after the moon formed from a debris disk, the leading theory of the formation of the moon, about 4 billion years ago. And then again, there was another window where life could have happened during a peak of lunar volcanic activity around 3.5 billion years ago. So in this report, scientists say that the moon, they think that the moon was spewing out large quantities of gases, of volatile gases, including water vapor, from its interior. And then they point out that this outgassing could have formed pools of liquid water on the lunar surface and an atmosphere dense enough to keep it there even for millions of years. So in this study, the researchers say that if liquid water and if you had liquid water and a significant atmosphere in the early moon for a long period of time, then they think that the lunar surface would have been at least transiently habitable. So this study, of course, draws from previous results on other space missions, and also, of course, from soil samples that we have taken from the moon that have shown that the moon is not as dry as we had previously thought. So, for example, in 2009 or 2000, more or less in 2009, 2010, an international team of scientists has discovered that there were hundreds of millions of metric tons of water ice on the moon. And they also said that in addition to this, the early moon is likely to have been protected by a magnetic field. Then that's good. That could have shielded any potential early life forms that were on the surface from deadly solar winds or cosmic rays. They also speculate in this study that life of the moon could have originated much in a similar way as it did on the Earth. Uh, but they say that one of the most likely scenarios is that it could have been brought in by a meteorite. So the earliest evidence for life on the Earth comes from fossilized cyanobacteria that are about 3.5 to 3.8 billion years old. And this is a time where the solar system was dominated by frequent and giant meteorite impacts. And it is possible, therefore, that meteorites containing simple organisms like cyanobacteria could have been blasted off the surface of the Earth and then landed on the moon. Yes, so they say that then in the future, one promising line of inquiry for future space missions would be to obtain more samples from deposits from the period of heightened volcanic activity to see if they contain water or other possible markers for life. And they also pointed out that you could also do more direct experiments in simulated lunar environments on the Earth or even on the International Space Station to see if microorganisms can survive under the environmental conditions predicted to have existed on the early moon. And yes, of course, this is one of the main reasons why we are very interested in the history of the moon. And this is actually one of the main science objectives that we're after when we count craters of the moon, which is, as I was pointing out yesterday, is one of the projects that you can participate in CosmoQuest. Because by counting the number of craters, if we get to know the distribution of number of craters on bodies such as the moon or Mars, then we are able to know more about the history of these bodies. Okay, and the second story that I wanted to mention today has to do with the Milky Way and its neighbor Andromeda. And actually, it's a story about a lost sibling. That's how they call it in this press release. And they call it like that because scientists actually have deduced in a new study that the Andromeda galaxy M31 has shredded and cannibalized a massive galaxy 2 billion years ago. So this is a massive galaxy that left behind a rich trail of evidence. So you can see it's like an almost invisible hail of stars larger than the Andromeda galaxy itself. But also you can see also some stream of stars, and the Andromeda galaxy has a companion, a very small companion compact galaxy that is very odd, is very weird from other galaxies that we know, that is called M32. So as we remember, Andromeda galaxy is M31. This other galaxy is called M32, the one that we can observe today. So this galaxy that was disrupted away, they have named it M32P. And then they say that it was the third largest member of the local group of galaxy, the two largest ones being the Milky Way and Andromeda itself. So this is a research published in Nature Astronomy today by researchers mainly from the University of Michigan. And yes, the researchers point out that a galaxy like Andromeda was expected to have consumed hundreds of its smaller companions. So they were observing of this halo of stars surrounding Andromeda, and then they thought that they could come from multiple sources. But then using computer simulations, the scientists were able to understand the formation of Andromeda. And then they did find that many companion galaxies were consumed by Andromeda in mergers, but most of the stars in the Andromeda's outer faint halo were mostly contributed by this galaxy that we call M32P that existed in the past. They say that this galaxy could have been very massive, making it the third largest galaxy in the local group, as I said. And this is a subword that also might help us understand a very long-standing mystery regarding that other galaxy, compact galaxy that we observe today, that is a satellite of Andromeda, that is M32. Scientists point out that M32 is a very weird galaxy because it does look like a compact example of an old elliptical galaxy, but it actually has lots of young stars. So they point out that maybe it could be that this galaxy M32 is the result of this merger with M32P, and it's actually the surviving center of that old galaxy M32P. Yeah, the researchers said that the method used in this study, of course, can be used and can be applied for other galaxies, and then you can actually learn about the measurement in other the merger in other galaxies instances, for example. And then scientists can start better understanding the effects that drives the galaxy growth and learn about what mergers actually do to galaxies. So yeah, that was also something very interesting to me that I actually didn't know about. So it's pretty cool. And then the final story that I wanted to share today has to do with the solar system and one of Jupiter's moon, Europa. So recently we found out that Jupiter has 10 more moons, and it has now like 79 moons or so. But ever since the time of the Galileo mission back in the 90s, We have had strong evidence that a global ocean underneath Europa might exist or exist actually. And scientists have considered that this moon is one of the most promising places in our solar system to look for ingredients to support life. Um, and there's even evidence that this water from this ocean is actually going out to the surface on the from the moon interior up to the surface of the moon. And scientists hope that by studying the material interior to Europa from this ocean, they could hope to learn about possible habitability of the ocean, of that ocean itself. Well, there is a problem, of course. Then the surface of Europa is constantly bombarded by an intense blast of radiation that is coming from Jupiter, and this type of radiation could destroy or alter the material that is transported from the ocean to the surface. So this makes it more difficult for science to know if it actually represents conditions in Europa's ocean or not, or if they have just been changed, the molecules have been changed by the radiation. So scientists, of course, are planning exploration of the moon, Europa, but then they have a lot of questions, a lot of unknowns regarding this type of radiation. Where is it most intense, or how deep do the energetic particles go? How does the radiation affect what's on the surface and beneath? Because this type of radiation could affect potential chemical biosignatures that could indicate the presence of life. So, and this is a study led by a researcher from the Jet Propulsion Laboratory, and it was published in Nature Astronomy. And the researchers point out that they actually want to know exactly what they're looking at when they look at the material that comes up from the subsurface. So they want to know if this material is actually telling us about what is in the ocean, or is this what happened to the materials after they have been radiated. So they actually use data from Galileo's flybys to Europa about 2 decades ago, and even measurements, electron measurements from Voyager, for one of the Voyagers, Voyager 1. And they look at the electrons that were blasting the moon's surface. And they found out that the radiation, of course, they vary by location. So it's not a uniform shower of radiation. And they found out that the harshest radiation is concentrated in zones around the equator of the moon rather than in zones close to the poles of the moon. But they say that this is the first prediction of radiation levels at each point of the surface of Europa. And this is important because it gives us information that we can use to plan future missions to Europa. They actually, in addition of doing this two-dimensional map, they did a sort of three-dimensional map that is telling us how far below the surface of the surface the radiation penetrates. And then this is also an important result because it tells us how deep scientists would need to dig or drill during a potential future Europa lander mission to find any biosignatures that are not contaminated or not affected by the radiation. So they point out that they say that at the highest radiation zones, you would need to dig a hole of about 4 to 8 inches, not a lot, but still it's telling us about the penetration depth of the radiation for the largest for the intense radiation zones, and for the lesser radiation zones you will have to drill a hole of about half an inch or so, which is not a lot, of course, but it's important to know these bounds and these limits to actually figure out what to do when we actually send a mission to Europa. And this is important because there is a mission called the Europa Clipper that is being planned to be sent, I think, in 2022, as early as 2022 or something like that. And it will carry cameras, spectrometers, radar instruments, plasma, and the objective of Europa Clipper will be to study the surface of the moon, to study the ocean itself, of course, and the material that has been ejected from the ocean line underneath the surface. So yeah, so that's what I wanted to tell you guys today. So let's check what you have to say regarding this news. If you have any comments or any questions. So let's say hello to everyone. Paranor 001, DPI 209. Hello, Dave Killins, Noel Hexacosikoran. It's always a challenge for me to pronounce the names. It's kind of cool. Hello, Larry, Weird and Proud. And hello, everyone. Yeah, life on the moon blows my mind. Yeah, me too. That was yeah, very interesting to read about this news. But on the other hand, yeah, I mean, it has happened so much time since the formation of the Earth 4.5 billion years ago, the formation of the moon. That is very interesting to know that how in the past, how conditions change, right? And maybe how in the past there were totally complete different conditions, and that could have actually harvested life, or some sort of life. And then it shows that as time goes on, then those conditions might change, and maybe life is not being supported anymore. So MA a fighter 23. Hello. The fine young cannibals. Yes. Regarding the second news of the day. Hello, Perpy Town. Hello, Star Womb. Europa would be the first place to drill. Yes, I'm looking forward to this Europa Clipper. And one interesting anecdote I remember when I was working at JPL last year, I think there was one congressman visiting, and this person, he was very vocal about supporting Europa. The Europa Clipper, sorry, mission. I remember that, and he was, I think, a representative from the state of Texas, and yeah, it was. They were joking around how regarding space missions was one of the few things that both parties actually agreed on, which I think is good. Should be independent, but yeah, very looking forward to this mission and see what we can find in Europa, especially if it's promising. If I were the king of NASA, would you favor a Europa plume sample and return instead of a Europa Clipper with no lander? That's a good question. Yes, I guess I would stay with them. I don't know. I will have to have a sample back, but I recognize that that's very hard to do. But I wonder if we could send like something smaller, like could go through the plumes, something of the not that doesn't require like a lander, like something huge or something too complicated. And if we could design some sort of drone or something that could go and then take samples and maybe somehow send them back. I'm actually sending a drone to, I guess, to Mars or to some other part of the solar system. That was one of the ideas that people had at JPL. They used to organize this like pitch your idea day where you could go in front of the higher ups at JPL. And then there were ideas about cosmology. One idea was about like mapping the whole universe, like with the largest telescope ever built and send it to space. And there were all these let's not call them crazies, but like out of the box ideas. And I think like one of them was sending something that could actually return, but something that is not too huge, or maybe like the opportunity thing that is the size of a car, right? But of course, it's doing a lot of important stuff in Mars. But it would be cool to send something that would be easier to return. But yeah, I think that this was one of the ideas in one of those JPL pitch your idea days. So yeah, pretty cool. If the moon was captured in a Terran collision, I wonder what possibility that if there was life on Earth already that may have gotten carried over. Yeah, that's I think one possibility. I don't know about the exact numbers. How would you quantify that? Because yes, of course, you would have to study the nature of the collision and then try to devise mechanisms in which a sample from that type of whatever life organism could go into the moon. But then I would think about how robust this type of of organism is. So we know here on the Earth that in very extreme environments, you can still find life. So we know of organisms that are very robust, so to speak, to dire conditions. But when you have usually such a sudden change, I guess like a collision, then that is a problem of time scale. I think I find that life can adapt as long as you give it time. If you give it time, then things are okay. The problem is when you have these sudden changes in time that then life, I think, starts finding more of a problem, which of course makes me think of climate change and all the species that may go extinct. It's not more like the problem that the climate of the Earth is changing, but it's that the time scales in which it is doing it. Um, yeah, anyhow, I started wandering off other ideas. I think everything tried to connect everything. Aren't the Europeans returning NASA's collected samples from Mars 2020 rover? Maybe, I don't know. Are they? So yeah, sorry for that. I don't know. That's something I guess we could Google. It's a question from DPI 209. Um, yeah, and then of course Paranors 001 has replied that yes, that's the plan. Thank you. Russia, Larry points out that Russia failed at a sample return with Phobos, and we should make that happen. Yeah, I think that's definitely one possibility. Yeah, so I think yeah, we should try like this different type of non-conventional approach to exploring the solar system, especially now, of course, as technology advances, that opens new possibilities. And I find um, encouraging that places, for example, at JPL, where these things happens, that they organize this type of days, like encourage people to think out of the box and to come up with these ideas that, of course, some of them might result in ideas that we can actually do and have a very high payoff. So yeah, I think in general NASA tends to be a very conservative agency, using technology that has been tested and trying, of course, to maximize the use of the public money. But then on the other hand, I think there should be room for some risk, some new ideas, and try to explore these other parameters space, within within reason. So yeah. Oh, thank you, Paranor 001, for posting the link to the sample return mission. That's pretty interesting. Um, yeah, so it was very interesting today. Do you guys have any more comments? I always like to read your comments, and thank you for for sharing the information in the chat. sharing with all of us. And I don't see any more comments or questions. So maybe I can call it a day today, a little bit earlier than yesterday. But tomorrow I will come back, and then once again, as I mentioned, Dr. Pamela Gay is receiving a very cool award uh, for her work as a podcaster. So that's amazing. Um, so today I'm hosting on her behalf, and tomorrow as well. So, but yes, thank you so much, everyone, for watching. This has been the Daily Space, and it is a production of CosmoQuest created by the Astronomical Society of the Pacific. Our goal is to put science in your brain. So please give us a follow, or please consider subscribing. And the Daily Space will be back tomorrow, as I just said, and every weekday at 1 p.m. Eastern, 10 a.m. Pacific, and 6 p.m. London. Okay, see you everyone. Bye bye.